Today, we're going to dig into something really powerful, a framework that can take you from just kind of knowing a topic to truly, deeply understanding it. We're going to break down how you can make complex ideas actually stick, for good.
I mean, we've all been there, haven't we? You spend hours, maybe even days, cramming a tough subject. You feel like you get it, and then a week later, poof, it's like it just evaporates. So the real question is, how do you stop that from happening?
Well, believe it or not, the answer we're looking at today comes from a pretty intense place, a quantum computing review session. But hey, don't worry, you definitely don't need to be a quantum physicist to get this. The method they use is what's so brilliant. It's a universal template for mastering pretty much any complex skill you can think of.
So, where does this whole journey to mastery start? Well, funny enough, it's not about jumping into new stuff. It's actually about hitting rewind. The very first step is all about reinforcing your foundation, making absolutely sure those core ideas are rock solid before you even think about building on them.
So the process kicks off with this really quick, rapid-fire recap. And look how they do it. They use direct comparison. By putting classical and quantum computing right next to each other, you're forced to sharpen your understanding of what makes them different. You know, like the huge gap between a simple bit that's either a 0 or a 1 and a qubit that can be both at once. This isn't just you passively glazing over your notes. It's you actively thinking about the distinctions.
Then bam, it drills down on the key definitions. Take a word like superposition. The goal here isn't just to recognize it, it's to have that meaning pop into your head instantly. It's kind of like you wouldn't try to write a novel if you didn't know what a noun was, right? This rapid review just gets all that essential vocabulary locked in.
And it's the exact same idea with a concept like entanglement. By hitting these big ideas one after the other, you're not just remembering them. You're actually strengthening the connections in your brain, making that knowledge way easier to grab when you need it for the tougher stuff later.
Okay, so the last part of this whole foundation building phase is super important. It's all about making abstract ideas feel real. The advice here is just golden. Connect the theory to something you can see or do, like a visual or a math problem. This is how you go from just memorizing a definition to actually getting a gut feeling for how it works. That's real intuition. All right, with that foundation solid, now we get to the heart of it. This is what I like to think of as the crucible. This is where all that passive knowledge gets hammered into an active, useful skill. It's where you find out what you really know and what you only think you know.
And what's so cool here is the step-by-step progression. It's like a three-part gauntlet. First, you have to tackle conceptual questions. Can you explain the why behind it all? Then you get your hands dirty with computational problems. You have to apply the math, the how. And finally, you get to circuit construction. You have to actually build a working system from the ground up. See how each step builds on the last? It forges a way deeper understanding. And if you look closer at the actual problems, you see just how smart this is. You're not just solving for X. No, each problem is designed to test one specific, crucial concept. You have to prove you get how systems interact, or show you understand entanglement, or apply a specific gate. Every single problem is like a laser-guided missile designed to find and fix a specific weak spot in your knowledge.
Okay, so you've nailed the theoretical stuff. You've solved the clean, neat problems in the textbook. Think you're done? Nope. Now the framework throws a real curveball. It tosses you into the messy, complicated real world for a final stress test.
This is where it gets real. You aren't given a clean problem. You're given a failure. An algorithm is broken. It's not giving the right answers. That one little sentence completely shifts your mindset. You're not a student anymore. You're a troubleshooter.
And your task is basically battlefield triage. Analyze the broken system, pinpoint what went wrong, come up with a fix, and then, and this part is key, prove that your fix actually works. This is what separates just knowing stuff from actually being able to do something with that knowledge when things go sideways.
So, you go through all that, the reinforcing, the problem solving, the stressful debugging. What's on the other side? Well, it's a huge leap. It's the jump from just practicing something to achieving genuine mastery.
So let's just boil it down. The big lesson here is that mastery is an active game. It's not about passively rereading. It's about actively reinforcing your foundation. It's using problem solving to forge that knowledge into a real skill, and then taking that skill out for a spin in the real world to build unshakable confidence.
And look at the payoff. This is the so what. You don't just feel smarter, you've actually consolidated incredibly complex ideas. You've measurably improved your critical thinking. And you've built a portfolio of work that proves you can do it.
You've gone from someone who's just learned about a subject to someone who can actually do something with it.
So, as we wrap this up, I want to leave you with a question, a challenge really. Think about that one thing you're trying to learn right now, that one concept that feels a little fuzzy. Instead of rereading the chapter or watching another video, what if you went out and found a real problem to solve with it today? Because that is where the real learning begins.